we have potential G. So how that potential G is related to force is what we need some idea. So just we'll do one thing. Let's have a, suppose a block is there. I'll release from rest. And we know we have discussed so many things here. The block is released from rest. It takes. Then it will come and strike the ground. Then by applying conservation of mechanical energy, what we can write, V equal to 2gx. And what was the potential here? mgx. Potential energy at this point will be 0 because x equal to 0 is what we have defined it. What was the force that will be acting on the block? It is mg. So how this potential energy and the force are related? That's what the question. So who is responsible for this kinetic energy? This weight mg only. The weight mg does work. Okay, because of that the kinetic energy will increase. Now mg is what? Conservative force, and when conservative force does positive work, potential energy will decrease. You have this equation. So when conservative force does positive work, potential energy what happens? Should decrease. When conservative force does negative work, potential energy increases. This is very important. So somehow that force and potential energy are related. So they are related by equation F equal to minus du by dx. Sir, how do we will not agree this? Okay, we'll know potential energy is mgx. Let me differentiate it. So that du by dx is nothing but mg. And what is mg? Mg is nothing but a force. How do, sir, how you can write F equal to du by dx? I'm just giving a very simplified explanation. So mg is nothing but force here only, no? This is nothing but equal to F. So therefore, how they are related? They are related by this given equation. And you can see in this given problem, x will decrease here. So minus dx, no? Or you can put like a potential energy decreases. Potential energy decreases. So why negative sign? For conservative force, we have to bring it like this. For conservative force, negative sign will come. The force related to conservative force by minus du by dx. For non-conservative, it will be F equal to du by dx. Of course, for non-conservative, you should not define potential energy. This we are going to discuss the next week syllabus. But if you know potential energy, can you bring a force? As this is a formula. And for conservative force only, this is applicable. I am making clear. Now we have the potential energy here. So let's differentiate this equation. We'll see anything can be obtained. So du equal to 10x minus 20 dx minus 20 into dx. So du by dx equal to 10x minus 20. So now we know F should be equal to minus du by dx. So therefore this will become F equal to minus 10x plus 20. Find the maximum kinetic energy of particle during subsequent motion. Find the maximum kinetic energy during subsequent motion. And it's under influence of a conservative force is telling. So when a conservative force acts, the total mechanical energy must be conserved. The total mechanical energy, the overall energy of a system must be conserved here. And the particle is released at x equal to minus 3, where the potential energy, where the kinetic energy is maximum. So the total mechanical energy will remain constant for a conservative force. Then if U is kinetic energy is minimum means U should be, if kinetic energy is maximum means U should be minimum, because overall mechanical energy remains constant. So this E will be a constant. Why constant? because mechanical energy must be conserved in a conservative field. So therefore now what is the condition we'll write? This E will be like this. Kinetic energy will be maximum where potential energy will be minimum. Because overall mechanical energy should be conserved here. And the sum of both should be equal to, that should be equal to E then. Now he is telling we have only information of the potential energy. Now he is asking us that maximum kinetic energy.
Could you explain once again, sir?
Nothing is there not explaining. Please understand the overall mechanical energy must be conserved. That should be equal to sum of potential plus kinetic. Where potential energy is minimum, there kinetic energy will be maximum. Okay, I accept this condition. No. How to calculate minimum? Go back to maximum minimum concept. Okay, let's differentiate this one. du equal to 10x dx minus 20 dx. Already we have du by dx, that one. Our potential energy should be minimum. So shall I go for du by dx equals 0? So 10x minus 20 equals 0. So x equal to 2 meter. Where it will be minimum? At x equal 2 meter. So let me substitute that x equal to, so the u minimum I'm going to obtain 5 into 2 square minus 20 into 2 plus 2. 4, 20 minus 40 plus 2. So minus 18 joule. The particle is released at x equal to minus 3. Okay, we'll take help of, sir. What is use of that? We'll see that one. So there's a minimum potential energy. I think all of you know plot graph. You plot the graph, from there also you'll get information. No. Okay, U minimum we got it. We wanted K max, no? So how to get the total mechanical energy? What all the system possesses energy, it is sum of potential plus kinetic. It is released from rest. The particle is released at x equal to minus 3. At x equal to minus 3, what is the state of particle? Should be at rest. Then what all energy it must have, it should be in the form of potential energy only. And do we know potential energy at x equal to minus 3? I'll substitute here. So now this I'll find out like this. After this, okay, now we'll find out U3, I'll write it 5 into minus 3 square 20 into minus 3 plus 2. 5 9 jar 45 plus 60 plus 2. 107 joule is what? The potential, where at x equal to minus 3 this is. And we know it is, particle is released from rest at x equal to minus 3 meter. So what should be the kinetic energy? Will be 0. The overall mechanical energy must be constant. So U3 plus K3. U3 is how much? 107. This is 0. Okay, this is a total mechanical energy. Now we have to calculate that K max, no? So E equal to U minimum plus K max. So 107. Do we know U minimum? Minus 8. So I'll get the K max. (125 joule). Okay, like this we can, this is something from potential energy we can find out so many things. So as it is a conservative, overall mechanical energy should remain constant. Then if potential energy increases, kinetic energy should decrease. If potential energy is minimum, then kinetic energy will be maximum.
Sir?
Hmm.
Sir, U3 can we call maximum potential energy, sir?
That's all.
Okay, sir.
Because where contingent is 0,
Yes, sir.
that conservative force, because of that we are able to think, otherwise not possible, no? Because overall mechanical energy will remain constant for a conservative field. That is a very important part of idea.
Sir, even maximum x coordinate is also asked, sir.
What to do for that?
Displacement you have to calculate.
When its kinetic energy is 0, no? When total mechanical energy is how much? 107. So where kinetic energy is 0, check it. When potential energy becomes equal to 107 joules, that's all, no?
Yes, sir.
When U becomes equal to 107 joules, kinetic energy must be 0. Okay, then with that we'll calculate the maximum x coordinate. I'll proceed here. When U equal to 107 joules, x will be maximum. 107 is equal to 5x square minus 20x plus 2. Quadratic equation, I'll get minus 3 meter and x equal to plus 7 meter. So which is the maximum x coordinate? So we are not understanding really what you are doing. For a conservative field, what is it? Total mechanical energy is equal to sum of potential plus kinetic. And the sum of potential plus kinetic is total mechanical energy. Where potential energy is minimum, kinetic energy should be maximum. Where kinetic energy is minimum, potential energy is maximum. Then what is the maximum x coordinate means? Where the particle will come to rest. So where all it will be at rest, the particle will be at rest at x equal to minus 3 and at x equal to plus 7, because they are the extreme points. So we'll add that information also. Will be at rest at points So if they give potential energy, how to get the force? Differentiate. All the potential energies given will be for conservative field only. Take it for granted. I am making clear. Whenever I say potential energy, it is different for only conservative field. Potential is different only for conservative field.